This is Steve from Hezico, and today I'm going to simplify vector databases for you. In traditional databases, we have rows and columns of data, and we pass in something, let's say cake is sweet, a string. Inside that traditional database, it will have an ID against it, which we can query to get that data. But let's say if we pass in something that it does not exist on the database, it will just return that it does not exist. But in case of vector databases, this does not happen. We take that data that we pass in as a query, we convert it into vectors, and using that embedding models that vector databases run on, we can come up with results that technically we didn't store in our database. Now today we're going to set up a simple vector database in Python, and I'm going to teach you what similarity scores are, how we can use them, and how other companies use them to basically predict patterns and predict how data flows through their applications, and how we can use these to power context-based applications that we create. So let's get started. Okay, so now we're at VS Code. We're going to set up a simple ChromaDB project where we will set up a vector database inside of ChromaDB. The reason I'm using ChromaDB is because it's air gapped, and we can use the online version as well if it's needed. But for this case, and generally for our use cases, because we're working with enterprises, we tend to use air gapped solutions. So we're going to just use the offline version of ChromaDB. So let's get started. So what we want to do is start a new project. So let's open folder. Let's just create a new folder. Go folder vector db and open. Okay, so firstly, let's open terminal. We're going to use UV because on our other tutorials we're using this as well. UV init and UV add chroma db. It's going to install the necessary packages. Okay, so now that our packages have been installed, let's create our database. Okay, so for this we're going to initially import ChromaDB, then we're going to say my database equals chromadb.client. Okay, so we have basically initialized the ChromaDB client. Now let's create a collection equals my database dot get or create collection. Okay, so this is an internal function that will basically create the database that we're about to initialize. New db, and then let's say collection dot add. We're going to add stuff inside this database. So we're going to say documents equals, let's pass in some documents. These can be strings, these can be, we can also pass in metadata. We can also pass in documents that are actually documents by converting them into strings. For this use case, we're just going to keep it simple and just use strings. So we're going to say apples are crunchy, red fruits. This is basically to give the embedding model inside of the vector database some context, and we can just copy and paste this. So we have, okay, so we have some IDs and we have given it context on what is what, right? Now the database is pretty much ready. So we can say results equals collection dot query. We're going to query the collection, and we're going to say query texts equal, we're going to query, okay, so we're going to ask it for a tropical fruit, and then we're going to say n results. So we generally it gives us 10 results, but we can limit it to 2. And let's do a print results. Let's clear our terminal. We can say uv run python main.py, and we have an issue because query tag, oh, we forgot a comma. Let's see. Okay, So now we can see that it basically runs this, right? And it gives us the tropical fruits like banana and apple. And also, using those IDs, it basically gives us the tropical fruits without us mentioning what tropical fruits are, right? Because even in our documents, we didn't mention that it is basically a tropical fruit. Okay, so now that we have gotten the result, we can see that our data is sorted based on the similarity score of our query. So we know banana is more tropical than the apple. So it has sorted it based on that. So we get these distances, which are the distances from the query to the vector itself in that n-dimensional plane that I mentioned in the start. Now, Chroma uses L2 to calculate these distances. We can also use cosine similarity. The reason Chroma uses L2 is because it's faster than using cosine similarity. Now, what we did in this video is basically had a database of normal sentences, asked the database a vague question that we can't do with a relational database, and we then got the answer based on those similarity scores. Now, imagine that we have a system where we have 10,000 documents, multiple tickets, and we have our entire knowledge base. And using these vector databases, we can create our relationships between similar questions and give our users more guided answers. So that's why multiple bigger tools are using these in our daily implementations, where we don't notice and we think that these are complex algorithms, but behind the scenes, these are just vector databases. And now you can make your own vector database on your own knowledge base. And this was a pretty simple implementation where we didn't use filters and stuff, but in part 2 of this, I can add filters, I can make something more complex. So let me know if you want that. And I will catch you guys in the next part. Thank you for watching.